Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology, and everyone, welcome into the program. I hope that you're doing well and you are ready for the show today because, well, I would say, we have something really special lined up for you, but I must say, Ralph has something very special lined up for you, and he is our science and technology trends correspondent. He put together an amazing show, and yeah, everyone, all you have to do is sit back, relax, and enjoy as we really visit a bunch of different topics that, some you may have heard about. This thing like AI, it's a crazy new thing. And we have stories that concern anything from AI to robotics. Ladies and gentlemen, the show today is going to be a great example of what Ralph does every single Friday. And you can find those segments at computeramerica.com. At the top, we have a section dedicated to Ralph only if you want to find his segments. And of course, you can go back and find past ones and the show notes. Now, the show notes, by the time that you hear this, you will be able to find those on the website. And these are all of the links, all of the sources, if you want to check them out yourself, if you want to dive just a little bit deeper than we do, then please come on out to computeramerica.com. Find today's show notes or any show notes, and you can find them right there. Also, thank you for listening on any podcast service. You can find this wherever podcasts are heard, and YouTube. So, with that being said, let's go ahead, bring Ralph on, and just have fun with it. Once again, science and tech trends correspondent that joins us every Friday to do another show. And Ralph, welcome back onto the program. How you been?
I'm doing great. It's always great to be here. And friends, if you're brand new to the show, I want to explain what Ben and I do every Friday. What we do is we highlight 4 articles that show us key trends and developments in all things science and tech, including, of course, artificial intelligence. As Ben was saying, it's kind of everything. Robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, construction technology, space research, physics, on, you name it. But most important of all, this is a key thing about what we do every Friday after the kind of news week we've been experiencing. What we do, we're going to give you hope for a better future thanks to the amazing breakthroughs happening every single day in the world of science and technology.
Absolutely. And I think a great place to start would be normally story number 1, but you even have, just for those who are completely new, Ralph does this thing where, he'll kind of take an aside, explore a topic, within a topic. And normally those are reserved for, stories 2, 3, when he kind of has you warmed up. Ralph, you are starting in strong with, a completely new topic before story number 1. So let's talk about that and then story number 1.
Yeah, I just stumbled across this term this week and I thought it was pretty interesting. So a key trend to watch. And by the way, friends, what we do is 4 stories every week. And as Ben was saying, I insert little tutorial things when I don't understand what the story's talking about and so forth. But this is a little bit of a different situation. I stumbled across this phrase, agentic AI. That's AGENTIC AI. And what that refers to, and I thought this is interesting, to artificial intelligence systems that don't just respond to prompts. So, for example, you say to, a ChatGPT or Gemini or Copilot or whatever, say, oh, well, take my picture and make me wear a coonskin hat or something. Mm-hmm. That's telling it or asking it to do something. So instead of that, these agentic AI systems pursue goals, make decisions, take actions, and adapt with minimal human supervision. Think of it as a shift from smart tools to autonomous digital workers. So agentic AI, I just thought it would be fun to share that with the viewers and listeners this week.
Yeah, it's for artificial intelligence being artificial intelligence, it does sound like the next step towards maybe a little less artificial because, it's something sitting there patiently waiting for an input. It has, like you said, its own goal. So yeah, even less artificial, but still more intelligence. Interesting.
Well, yeah. And you know what, Ben, you think about things like Alexa on Amazon devices and so forth, and where it might go, you ask it something and then it might go, but Ralph, if you're interested in that, how about consider this? That's an example of agentic AI, that follow on.
Gotcha. In which the way that you put it, just like that, it sounds like, okay, so that's how they're going to get ads into AI. But yeah, quite possibly.
Yeah,
so,
good one.
Yeah, so there you go. So now we can go from there and just follow AI to AI right into story number one.
Yes. Yeah, story number one I picked up from the BBC, the British Broadcasting Corporation, of course. Headline, AI model from Google's DeepMind reads recipe for life in DNA. Wow, this is really interesting stuff. And of course, in the show notes, we have the links and usually have pictures and sometimes links to videos when it's applicable. But here we go. Google DeepMind has developed Alpha Genome, an AI system designed to interpret DNA at an unprecedented scale. And a little side note here, Alpha Genome is Google DeepMind's large-scale AI model designed to decode how DNA works, especially the regulatory non-coding regions that control when and how genes are expressed. This is geeky, folks. It's essentially a unifying model for predicting many different molecular behaviors directly from raw DNA sequence. And this is important. This represents a major leap in computational genomics because it can analyze very long stretches of DNA, up to 1 million base pairs, and predict a wide range of biological outcomes with high resolution. So friends, this is very, very geeky stuff, but very, very important.
Yeah, it sounds like it's going to come up more and more, just to go news to news. Like just the other day, I was reading, I think it was AP News. Well, I mean, I have the article right here if you're watching the video portion. But Ralph, this was, we won't go into this article, but I found it very fun because they found a way to use CRISPR, which has been mentioned on the show before.
Right.
And they turned off, two different study groups have two different genes that they turned off with CRISPR. And obviously, Ralph, you wonder, if you turn that off, well, is that going to make like your toenails grow backwards or something? But, they turned it off, and Ralph, they, at least I think they only tested on like 20 people so far. 20 people had their bad cholesterol cut in half for 2 years with no pills, no drugs, just a one-time CRISPR therapy, and then now their bad cholesterol is cut in half. So,
fascinating.
Yeah, maybe being able to read more genomes, be able to see the side effects of something like this with AI. But, Ralph, this is going to be very important, I think, going on, like a big area of research.
Absolutely, absolutely. So going back into the story here, researchers believe Alpha Genome could transform our understanding of how DNA works, especially the parts that influence disease. And why this matters? Well, subtle variations in DNA can increase risks for conditions like high blood pressure, dementia, and obesity. And that's just a few examples. Alpha Genome may help scientists pinpoint why these variations matter and how they contribute to disease. And here's a really interesting part, friends. I don't profess to understand this. This is very, very geeky. It talks about how this research can unlock what are called dark genome. Only 2% of human DNA codes for let me try that again. Only 2% of human DNA codes for proteins. The remaining 98%, often called the dark genome, regulates how genes are used, but is poorly understood. Many disease-linked mutations are found in this region, in that 98%. Alpha Genome can analyze 1 million DNA letters at a time, helping researchers decode this vast, complex area. Again, 98%. And in the show notes, I have a side note inserting a little tutorial about what DNA letters are. So DNA uses 4 chemical bases, often called its letters, to encode genetic information. You can come to the show notes at computeramerica.com and dig deeper into that through my little insert if you want to. But together, here's the key. Together, long sequences of these letters make up genes and ultimately guide how living organisms are built and maintained, just like Ben was mentioning the bit about editing genes and having its impact on weight gain or other biological processes. That's what we're talking about. And scientists who've looked at alpha genome from Google, DeepMind, they describe it as an incredible feat and a major milestone. So this is big stuff.
Yeah, I can only imagine that, Ralph, even 5-10 years ago, before these models were widely available for scientists to use, I mean, you had the 1 million sequence DNA sequence, the 1 million DNA sequence, but you had to kind of read it yourself and kind of parse that data yourself. And that's where AI, and I'm sure everyone's sick of hearing AI by now, but that's why it's so revolutionary, is
Yes.
that it can do things that humans just cannot do easily themselves. So,
That's a great point. And it's a good point. It's a good example, Ben. You and I often try to focus on the positive side of AI. Day after day after day, we hear about it's going to take jobs away. It's going to destroy this. And there are some serious consequences of AI. I'm not denying that. What we try to do every Friday, in part, is show the positive side of AI. And oh my Lord, when it comes to medical research, such as this example, it's undeniably a miracle. So good stuff there on a positive note. And DeepMind, however, the team acknowledges the model they've come up with isn't perfect, but sees it as a powerful tool for advancing genetic research. And of course, it'll just get better and better and better over time. Potential impact could accelerate genetic disease research, including cancer. Yeah. And it may speed up drug discovery by revealing how genetic variations affect biological processes. So, good stuff.
yeah, we're hoping that AI really does usher in kind of not even like something that we're doing different, but something that we can do faster. That's a very good use of AI. So yeah, and once again, DeepMind, which is I think that OpenAI and Anthropic and these other big tech companies kind of get a lot of attention. But Ralph, DeepMind was kind of first Deep Blue, and then that became DeepMind, and it did the whole Go thing, and it's been 6 years. Ralph, it seems like forever that we were just applauding that a computer beats a Go champion in the game Go,
Right,
AlphaGo,
right.
if you remember that whole story.
Yes.
It seems like ages ago, but that was probably less than 10 years ago. And now look what computers are doing.
Oh, yeah.
It's always fun to kind of zoom out, take stock, but hey, it's only going to get faster and better. So we'll see. Story number 1, amazing. Story number 2, let's go ahead and scroll on over and let's talk about, robotics. And this one is once again that cross section of something you think is very low tech and high tech. Let's get into farming and robotics.
Yes, this is another great example of positive application of artificial intelligence. So this comes from Business Wire. And the headline here is Carbon Robotics. That's the name of a company. Carbon Robotics launches the world's first ever large plant model. So large language models and artificial intelligence talk about all the information that's used to create the artificial intelligence decisions or prompts or whatever you want to call it. This is called a large plant model, and you'll understand as soon as we get into it. And there's a cool video on this too, by the way. Let's get into this. Carbon Robotics has unveiled what it claims is the world's first large plant model, a groundbreaking artificial intelligence system trained on an unprecedented data set of 150 million labeled plants. 150 million labeled plants. The new large plant model AI system promises a step change in how farmers manage crops. Get this, enabling laser weeding in a field or crop in minutes. Now, if you have the show notes, come out to computeramerica.com. You can look at the pictures here. You can see this large machine, large tractor, but with this array of scanners in front. We're going to explain what that is. The next picture shows a person holding a tablet where they're able to control this system. But going on, here we go. The large plant model continuously learns from real-world data gathered by Carbon Robotics' global fleet of laser weeder machines. These are these big devices that are put in front of a tractor, carried by a tractor, and go across a field, a row of plants in a field. Try to picture that if you're listening to us as a podcast only. So again, the large plant model continuously learns from real-world data gathered by Carbon Robotics' global fleet of laser weeder machines, creating a rapidly improving system for plant detection and identification. Little side note, Carbon Robotics laser weeder machines are innovative tractor-towed agricultural robots that use artificial intelligence, high-resolution cameras, and 30-plus CO2 lasers to kill weeds instantly with sub-millimeter precision. Wow. These chemical-free, sustainable tools are designed for specialty row crops, clearing over 200,000 weeds per hour and operating day or night. That one paragraph is just like blows my mind.
It's fun because I actually remember talking about these guys before. They had a system where they would zap weeds with lasers. This has been around for 10, 15 years. But Ralph, really rolling in the AI capabilities.
Yes,
of this, because
right.
we heard about this way before AI, but to be able to kind of decide what is farm plant, what is weed, that just kicks this to a whole new level, because before it was like, you kind of had a computer that would, hopefully just kind of recognize that this is cabbage, and everything that is not cabbage you destroy. But this makes it so much more smart, and be able to gather and improve and, adapt it to so many other crops, so much more quickly, that it's just really a match made in heaven to take what seems like an already futuristic concept and just kick it into high gear.
Absolutely. And that sub-millimeter precision of the laser firing is, okay, wow.
Really gets to the heart of the plants. And and by the way, just seeing the video and kind of seeing it, recognize.
Isn't that something?
Yeah. And just seeing it just kind of just zap these things right away. It's, Ralph, I wish I had one for my garden, but I don't know if I do row cropping, but this is really impressive.
Well, it definitely is. And the thing that's so exciting, I live in farm country. Well, it is kind of still farm company. It's being taken over by data centers, but we have some of the finest soil in the world here in the Tualatin Valley in Oregon, west of Portland, Oregon, where I live. But weeding is a huge problem for farmers. It's a constant battle. You think you have problems in your yard? You should try it out on, 500 acres. Anyway, going back to the story, key features and benefits of this system: precision technology utilizes artificial intelligence, computer vision to identify crops and weeds in real time, as we've been talking about. Efficiency: this system capable of clearing 2+ acres per hour. Environmental impact: well, it provides a chemical-free, no-till, meaning no tilling, tilling of the soil, right? A no-till alternative for organic and conventional farming. Whoa. And get this, Ben, operating conditions. This system works in various weather conditions, day or night. The machines are primarily used in large vegetable growing regions and are designed to integrate into existing farming infrastructure. And to wrap it up, this technology arrives at a crucial time, offering farmers a path to reduce reliance on labor and herbicides while boosting yields. So this has profound implications.
Really, and the next step that I could totally see, as they kind of use it and they kind of keep scanning and it keeps getting better and better, Ralph, with 2mm precision, like you were just saying. I don't see why this also can't be used for insects and invasive species.
Oh, interesting point.
Things that eat the crops. Because you can just have it, zap, even, let's say there's like a caterpillar or something eating the leaves of the plant, just zap those bugs.
Interesting.
Totally possible, I'm sure, eventually.
Yeah. So that's a kind of fun expansion of the possibilities. I love it.
Yep. So, just for everyone out there that's like, wow, I love eating organic, but it's so expensive. Hey, maybe as long as you're not against lasers, this is maybe the next step beyond that. So very, very cool. And story number 2, high tech. It's again always fun to see in the areas of agriculture, construction, so on and so forth. Just seeing how high tech they're getting. Story number 2. Story number 3. Let's go ahead and, hey, speaking of construction, let's talk about your next home. And this is where normally we'd launch into a big spiel about how we want to sell you real estate in Acapulco, but instead we're going to go ahead and do story number 3. And Ralph, 3D printing and construction has been around for a bit, but this is a bit different.
Yeah, this is definitely a new twist, really interesting. And this is kind of, we'll call it part 2 of things you might think are not high tech, but are going there quickly. Farming, we just finished with that. The other one is construction. We think of construction as just being, hammers and nails and wood and concrete blocks. But it's going very high tech, very fast. This is a good example. This comes from MIT News, their website. Headline, your future home might be framed with printed plastic. So we've talked about printed, 3D printing homes with a concrete mix and so forth, but this is all about using plastic. And I just love this story because it's a win-win story. We're going to find out exactly what I mean by that. So here we go. The plastic bottle you just tossed in the recycling bin could provide structural support for your future house. So this is the win-win part, recycling plastics and putting them to use in a really clever and new way. So MIT engineers are using recycled plastic to 3D print construction-grade beams, trusses, and other structural elements that could one day offer lighter, modular, and more sustainable alternatives to traditional wood-based framing.
Yeah.
Wow.
It's the way that I heard it a while ago that always clicked in my brain really well was like, people want to move away from plastic because they're so destructive for the environment, so on and so forth. But there's good uses of plastic where, Ralph, you consider, the side of a house and maybe plywood, and then you cover it with your Tyvek or whatever. And, just that thin sheet of plastic increases the lifespan of your wood by 20, 30, 40 years by keeping that moisture out. So, you're still using plastic in construction, but you're increasing the sustainability and the effectiveness of the material that you're using. So plastic is useful. It's just you have to use it intelligently. You can't just slap it all over everything.
Yeah. Oh, yeah, without a doubt. And in the show notes, there's a little insert here. You can go look at their research paper, which was published in an outlet called Solid Freeform Fabrication Symposium Proceedings. That's pretty cool. Check that out if you're real geek and want to get into the details. But going on here, a little remembrance here. The article brings this up. It says a traditional floor truss is made from wood beams that connect via metal plates in a pattern resembling a ladder with diagonal rungs. Set on its edge and combined with other parallel trusses, the resulting structure provides support for flooring materials such as plywood that lies over the trusses. So I think you can picture in your mind the traditional construction of a home. The MIT team printed 4 long trusses out of recycled plastic and configured them into a conventional plywood top floor frame. Then tested the structure's load-bearing capacity. Here's the key, Ben. The printed flooring held over 4,000 pounds, exceeding key building standards set by the U.S. Department of Housing and Urban Development. So that's pretty important. And the plastic printed trusses, they weigh about 13 pounds each, which is lighter than a comparable wood-based truss. And they can be printed on a large-scale industrial printer in under 13 minutes. You really need the show notes to see the pictures that Ben's showing you on the screen if you're watching us on YouTube. Really, if you're listening to us as a podcast, please come and look at this, because when you see these pictures, you go, oh, I get it. I see what's going on. It's pretty impressive.
Yeah, to be able to, not have to use wood for these parts of the house, and then they are stronger than their wood counterparts, and I'm sure resistant to rot as well because they are plastic.
Oh, yes.
You said this was a win-win. It's hard to see how this, and I'm sure, we'll kind of get into some of the reality checks that you have here, but it shows that it is viable. It's just, we need to get there. So
yeah. And trusses are just the start. In addition to floor trusses, the MIT group is working on printing other elements and combining them into a full frame for a modest sized home. Oh, that's cool. Now, a little reality check. Actually, before I get into the reality check I have in the show notes, a little aside, I just saw a story where researchers in Korea, South Korea, have developed a plastic that can withstand some fantastic temperature levels without melting. And so the one thing I did think about is if the house catches on fire, the plastic's going to be burning and emit toxic fumes and so forth. But maybe this technology from Korea combined with what the MIT folks are up to could be this winning formula that overcomes that. But back to the reality check I do have in the show notes. My son-in-law is a construction manager for Google. And I shared this story with him prior to today's show. And he said, in terms of a reality check, he said, well, this is, really super cool, which is what he said. Now code just needs to evolve to allow these innovations. A really good point. You can have all this research, you can have this new technology, but sometimes it takes years to get something approved to be used for actual construction in the real world. So let's hope this gets accelerated and gets deployed.
I am curious about some of the other, structural forces that they have to contend with. I mean, Ralph, you with your history know way more about construction than I do, but I'm thinking like, earthquake and shaking and shearing force and all that kind of thing. How does that stand up compared to traditional wood, with the twisting and pulling and bending? Obviously, load bearing matters. Maybe even if this never makes it into a home for safety reasons, like you said, or any other application. I mean, there are many kinds of structures out there that could still utilize this. Maybe not a house, but something even, a storage shed, something simple that you could put this together. So always find a use. But yeah, I'm sure they're going to keep refining this, and maybe we will not see it under your house one day. So very cool.
Yeah. And Ben, I'll pick up on something you mentioned in passing about my background in construction. For the last 10 years of my active career before retiring, I worked for Autodesk, the AutoCAD company, but in specific, I worked for the architecture, engineering, and construction division of Autodesk. And that was all about building information modeling, which also takes advantage of AI-like elements. So if you combine high temperature resistant plastic, the 3D printing the MIT guys are doing, and then building information modeling, which can look at a project and make very intelligent, knowledge-based decisions about the size of things, where to put them, how to move it around. If I do this, what happens here? You combine all that together and architecture could be fundamentally transformed as we go forward in the future. So architecture, construction, very exciting field.
Yeah, if there was a trend to pin it to, it would be this idea of new metamaterial or different materials that they are creating all the time. And yes, this is just plastic, but this is creating something new with that plastic. So
absolutely,
very cool. And always MIT doing amazing stuff. So story number 3, and we're going to go ahead and jump on over to story number 4. And this one is not smell-o-vision. Unfortunately, we're not there yet. Story number 4 is not smell-o-vision, but it's something that I did not really consider because, due to some health things, I've seen a lot of scans. They put contrast dye. They can see lights and darks, and they can see dense areas and thin areas and so on and so forth. But Ralph, the fidelity is always, if you've seen an X-ray from 1910 or whenever it was invented to today, kind of the same, looks very similar, probably a little bit better fidelity, but I digress. Story number 4 is allowing you to potentially see in color
and 3D.
And 3D too. Yeah.
Weird. Yeah. This is really cool. This comes from ScienceDaily.com. And the headline here is a new scan lets scientists see inside the human body in 3D color. Oh, you have to see the imagery. We've got a link here. We've got a link to the research paper in the show notes as well if you want to super geek out. But let's get into this. Researchers at Caltech and USC have developed a new imaging technique called RUSPAT. That's RUS-PAT, which stands for, get ready, rotational ultrasound tomography combined with photoacoustic tomography.
Rolls off the tongue.
Yeah, it does. So we'll go with RUSPAT. This system generates vivid 3D color images that reveal both the physical structure of soft tissue and the functional activity of blood vessels. Wow. And here's how it works. The device solves the limitations of existing tools by merging two technologies. First, ultrasound, which provides structural images of the tissue. And then next, photoacoustic tomography. Boy, that's geeky. Uses laser light to cause molecules to vibrate and create sound waves, allowing scientists to see blood vessels in color and observe blood flow. Okay. What? I got to say this again. Uses laser light to cause molecules to vibrate and create sound waves, allowing scientists to see blood vessels in color and observe blood flow. Wow.
I don't know what that would feel like. I hope it feels like nothing, but having your blood vessels jiggled, it sounds a little uncomfortable. But yeah, it's but I mean the output though is definitely night and day compared to what we used to do.
Yeah. And then you're going to love this next part. Instead of complex arrays, the team used a small number of arc-shaped detectors that rotate around the subject, mimicking a full hemispheric detector. This makes the system simpler, cheaper, and more practical. Okay, and key benefits? Well, here we go. Safety. Unlike CT scans or X-rays, it uses no ionizing radiation. And in the show notes, I inserted a little side here about why ionizing radiation is a bad thing. So this avoids that completely, unlike CT scans or X-rays, which have that issue. Convenience, it requires no contrast dyes and completes a scan in less than 1 minute. A 3D in-color scan with the capabilities it offers in less than 1 minute. And clarity, it offers detailed 3D views that CT scans or X-rays could achieve, that could not achieve alone, I should say. And potential applications, Ben, the technology has already been tested on human volunteers and shows promise for breast cancer analysis, pinpointing tumor locations while revealing biological activity. So it's identifying a tumor, but also revealing its biological activity, hence the blood vessels and things of that nature. Diabetes, monitoring nerve damage, neuropathy, and oxygen supply simultaneously. That's the combination of the tumor or the problem itself, but also its behavior. That's the key here in this scan. And brain research, studying brain anatomy and blood flow dynamics together at the same time. Bang, great stuff. And if this doesn't leave you feeling uplifted and positive about the future, I give up.
Yeah, no, it really does seem to, just give another axes of information for so many different areas of research and potentially preventative medicine. And yeah, it's Ralph, that is a very uplifting story. So everyone out there, if you've been following along with the show notes, again, computeramerica.com, you may notice there are a few more words on this page. It doesn't just stop there. That's where we hit the honorable mentions. And these are stories that, they're just as good, just as relevant. You should definitely hear about them, know about them. We don't limit the show to 4 stories just because we want, we're like, oh, that's it. That's all the good news there is. And yeah, hopefully next week there's 4 more. No, there's lots of news out there. It's just we don't have time to cover it. So, Ralph, we can at least give them the headlines and then come out to the website, find today's show, and find the honorable mentions over at computeramerica.com. So with that being said, let's again go with the headlines.
You got it. We've got 4 honorable mentions this week. First one comes from interestingengineering.com, one of my favorite sites. Headline: 3D printed passive cooling system cools data centers without fans or pumps. Pumps referring to water. A European project shows how passive cooling system can cut data center energy use and reuse excessive heat. This is really potentially very significant because, again, as longtime listeners of the show know, I live out in an area that's being gobbled up by data centers as our beautiful farmland goes away. But the use of electricity and water to deal with heat management and control in these systems or in these data centers is a huge, huge problem and challenge for the localities where I live and suddenly having to deal with this. But this is a great story about a very unusual, very kind of sci-fi looking device. You got to check it out in the show notes. It's just amazing. And then going on,
it does look like the heart of a cyborg. So yeah.
Oh, it's weird. It's fascinating. It's a great story. You should check it out, folks. Our next honorable mention comes from Google's The Keyword Blog. Another Google story this week. So from the Keyword Blog from Google, the headline, How We're Helping Preserve the Genetic Information of Endangered Species with Artificial Intelligence. Another positive example of AI being applied. A really interesting story. I'll just say one thing quickly about it. Google has launched a partnership with Vertebrate Genomes Project and Earth Biogenome Project to preserve the genetic codes of endangered animals. The project aims to create a comprehensive digital catalog of life, often described as a biological instruction manual, which is critical for future conservation efforts. Wow. I mean, you think about Google, some of the stuff their research people are doing is just sort of like a Google version of MIT. It blows my mind.
they do seem to have a lot of a lot of different balls in the air when it comes to the projects that they work on. It's Ralph. It's really amazing sometimes where you're like, okay, so they have that project, this project. I would love a full count of how many projects they have going on.
Oh wow!
It's huge.
Oh, it's overwhelming. And our next one, you folks, if you're listening to us as a podcast, please come and get the show notes because you must see the picture, the artistic rendering of what this is all about. Here's the story. It's from YD Design, which is a fascinating outlet, by the way. And the headline here is the Navy's Batwing fighter jet promises Mach 4 speed, but it's still just a concept. Well, what I would have said in the headline is this is the weirdest looking jet aircraft you're probably going to see for a while, and you got to see it and check it out. Fascinating story, fascinating technology. And a little excerpt from this, the SM-39 Razor, that's a fighter design so visually striking it demands a double take, amen. The triple fuselage Batwing configuration breaks from a century of conventional aircraft architecture, presenting a form that's more science fiction than traditional aerospace engineering. Amen. Check it out, folks.
Yeah,
very, very bizarre.
You see something like this in the air and you're going to say, well, aliens, they're here. So...
Yeah. And here's the last one. Our last honorable mention from livescience.com. Headline, New study of chemical reactions in space could impact the theories of origin of life in ways we hadn't thought of. Very geeky, but very, very interesting. Explores how the fundamental building blocks of life, specifically amino acids, can survive in harsh conditions of space by hitching a ride on cosmic dust. I think we all are aware that in science research, there's this theory that the elements, the key things that created life on Earth got here by hitchhiking on asteroids or whatever, going through space and landed on Earth, and the rest is history.
Yeah, no, it's still a very active field of research, Ralph, which is answering that question. How did it all start? How did we get here? What's up with that? So yeah, answering that age-old question of what's up with that is always on the plate. So Ralph, thank you so much for joining us. Thank you so much, everyone out there, for joining us as well. And really, 4 amazing stories, 4 amazing honorable mentions, as always. And ladies and gentlemen, if you enjoyed this, well, there's a lot of old episodes that you could definitely check out. They're all very cutting edge at the time that they were recorded, so they're still very relevant today. And well, if you want to hear more, next Friday, every Friday, Ralph joins us to talk more about this. So until then, I want to say thank you so much for tuning into the program. If you want to find out more, computeramerica.com. As always, you can find it right there. And Ralph, until next week, thank you so much. We'll see you then. And everyone else out there, we'll see you same place, same time. Everyone, have a good one. Bye, everyone.